Lasers, we are back again. Today we're going to be talking about parabolas. Okay. I'm just going to talk about parabolas in a very, or parabolas. I think it should be pronounced actually parabola. A parabola. Okay. Parabolas. There we're going to discuss them in just more of a general sense right now, to get an idea of what parabolas are, or really, first of all, parabolas come from the quadratic equation, okay, of y equals ax squared plus bx plus c. A cannot equal 0. Okay? And parabolas are going to look, remember correctly, we draw our little Cartesian plane. Parabolas either open up, okay, so y equals x squared looks something like this, but it could be over here, it could be like this, 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 okay, depending on the values of what a, b, and c are, will tell us whether a parabola points upward or downward, whether it's narrow or it's fat, whether it touches or it crosses the x-axis or not. All these things are dictated by the value of these coefficients, okay? A, B, and C, the value of my coefficients. All right, so let's start with a few things. Just a few understanding of things. All right, A is a very, very important term in parabolas. I think that C is too, but because C is a very important term in linear functions, but not once you're here, because that tells you where it crosses the C will tell you where it crosses the y-axis. All right, or sorry, when x is equal to 0, okay, let's tell you where it crosses the y-axis. But really, I mean, this is not. In all seriousness, I mean, this is really, I mean, this doesn't tell you too much at all, so don't worry about it much. A, in some sense, is a very, really important one. All right. If A cannot equal 0, if A is greater than 0, all right, the parabola is going to point up. It's positive. Our vertex is a minimum. Okay, so look, I think it's positive. Think smile. When he's positive, he smiles. He's got the minimum. He can only go so low. His upper limits know no bounds. Okay, his joy is boundless. Okay, if A is less than 0. Okay, if A is less than 0, remember, A can't equal 0. We have a downward pointing parabola. Okay, we have a downward pointing parabola. It's negative. It's negative. All right, and the vertex, which is the lowest point, the vertex is a maximum, and it is infinitely depressed. It keeps going down, 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 and down. All right. What else we need to know? We need to know where the vertex is. Oh, sorry. Let's just move that for a second. The absolute value of A. All right. If the absolute value of A is small, as it gets smaller, our vertex is going to get narrower. Sorry, our parabola is going to get narrower. And if the absolute value of A gets bigger, it's going to get wider. Okay? All right. So A gets smaller, A is narrower. Okay? All right. And these things kind of make sense. We look at this really quickly. Okay. We said that if A is positive, so y equals 3x squared, we can see that basically if x is 0, y is 0. If x is 1, y is going to be 3. It's going up. Or if x equals -1, y is 3. If x equals 2, well, that y is going to equal positive 12. Okay, 12. And we can see it's going to be this kind of probably look something like this. It's a very poorly drawn parabola. If y equals 1/3 x squared, well, we know that, again, if x is 0, y is 0, but if x is 1, y is only 1/3. X is 1, all right? X is 1, y is only 1/3. If x is 3, all right, y is 1, 2, 3, y is 3. And we see we're still pointing up, okay? And that makes sense. Because the value of x, because it's squared, is always going to be the value of x squared, because regardless of what x is, the value of x squared is always going to be positive, okay? And so that's going to be positive. And so if it's also, if the coefficient is positive, the y must always be positive. Conversely, because x squared is always going to be positive, if y equals -3 x squared, it's going to be just the reverse, right? If x is 1, y is going to be -3. Or if x is -1, y is going to be -3. If x is 2, y is going to be -12. If x is -2, y is going to be -12. And if y equals -1/3, again, this just tells you, this is the coefficient. The bigger the coefficient is, the bigger it's going to make this, all right? And so the bigger this coefficient is, the bigger y is going to be. Makes sense, right? And the same thing if y is 1/3 x squared, -1/3 x squared, is the same thing. We're going to have that same kind of wider parabola. And it looks like the Spider-Man logo, doesn't it? Spider-Man, Spider-Man. All right. So that makes sense to us. All right. We're going to find the low point. We're going to find the low point of a vertex at -b over 2a. And you may think to yourself, is the x value, okay, is the x value at the vertex? Okay, you may be thinking to yourself, well, I mean, how do we know that? Well, they never show you how to solve this in your pre-calc class, and the reason they never show you how to solve this in your Algebra 2 or your pre-calc class is because the way you get this is using calculus. You take what's called the derivative of it, and you'll take my word for it right now. The slope of the parabola at any given point can be found with the equation. Using the equation, all right, y prime, I would say, is the determinant. Y prime is going to equal 2ax plus b. Okay, and we know that the slope at any one point. We know the slope. Okay, if this is my parabola, we'll put another one over here. So with the positive parabola, we know that when we're coming down this way, on this side of the parabola, my slope is negative. Here it's positive. To get from positive to negative, you need to go through 0. Okay, you cannot go from negative to positive unless you go through 0. So at some point, the slope has to be 0. That point is the vertex. Okay. So 0 equals, and the same thing here, it's positive to negative, it's got to go through 0. Whether we have a smiling parabola or a frowning parabola, nonetheless, the vertex is the point in which the slope is going to equal to 0. It's going to be flat. Okay? All right? So basically, this is going to equal, 0 equals 2ax plus b, and then if we do our little quick algebra right here, -b equals 2ax, 2a, should be relatively simple, x equals -b over 2a. We're going to plug this -b over 2a into the regular formula we're using for our parabola, y equals ax squared plus bx plus c. X equals 2a, so that's negative b over 2a squared plus b times negative b over 2a plus c. Y is going to equal, this is going to equal a b squared over 4a squared plus negative b squared over 2a plus c. This is ab squared over 4a. A's cancel. I want to find the common denominator. I'm going to multiply this by 2 over 2. Okay, 2. And we're going to have, this is going to be negative 2b squared over 4a. This is b squared over 2. This is going to be b squared. This is going to equal to be b squared over 4a. So this is b squared over 4a minus 2b squared over 4a plus c. Alright, this is going to equal, negative b squared over 4a plus c. And so we see is that the equation of my vertex can be found at the x value is negative b over 2a and the y value is negative b squared over 4a plus c. That's a funky equation. It is hard to remember. You will save yourself some time if you can remember it. Okay, but of course you can always derive it, too, so you can remember what it is. All right. So these are my two equations. This is my vertex. Okay. And then was there anything else we needed to figure out? I think that was it. So there you go. Sorry, there was one more thing to figure out. There is one more thing to figure out. It's a very important thing too. I should remember this. Where does our parabola cross our axis, right? I mean, after all, we have our axes here, and we got our parabola. And we can definitely tell that there are some cases, my parabola is over here, it's never going to touch it. Here it touches it twice, here it touches it once. And the question is, how can we tell where it crosses the line? Well, x is going to equal 0. Sorry, y is going to equal 0 in this case. It's to the point where y equals 0. Remember our quadratic equation. We'll solve it later. Okay, but our quadratic equation is going to be if y equals 0, then x can be found negative b plus or minus square root of 4a, b squared minus 4ac over 2a. Okay? And if you solve this, there are some times where you wind up with a negative number under the square root sign. And when that happens, we say there are no real solutions, and you have something like this parabola right here. You can see that this parabola never ever crosses the x-axis. Y is never y never equals to 0, and so that's when you get this solution where you get a negative number underneath this this sign, and that's when you know that there's no solutions, that your parabola doesn't cross the axis. If you only get one solution, okay, if you only get the one solution or one real solution, then this is a situation where just the vertex is touching the x-axis. And if you get two solutions, you get this point where the two where the parabola is going to cross your axis twice. So those are everything you're going to need to know about a parabola.